Hello everyone and welcome to our skills issue of BRM. This time I'll be giving you a crash course on installing a stall action type point motor to your layout and building a plastic station building kit. But first, let's take a look at our layout of the month, David Westwood's Marsh Chipping.
The layout was built because of memories of days out in the Cotswolds. The memories of the buildings and everything around the landscape and that sort of stuck with me, and when I started building, it's one of the things that I really wanted to try and replicate. Well, the name is David Westwood. The layout is called Marsh Chipping. The name Marsh Chipping originated from a combination of Morton in Marsh and Chipping Camden, elements of both of which have been included into the layout, although it's not a copy of either in any specific way. It was always the intention to have a lot of greenery. The others that help me out always laugh about this, but I always tell people you can't have too many trees. And yes, the landscape was an important part to me of what had to go into the layout. Back scenes that are on here are intended to give a feeling of depth because it is quite a narrow layout, and in order to get it in the car, it had to be of a certain width. There was a maximum I could go to, so I had to try and get it all in a certain width, which is why it's only 2'6" wide and why the scenic side is only 1'3". My favourite elements are really just the cottages at the back and like the factory. It's just tucked away in the corner and it just tries to give the feel of the area.
I'm Hugh Griffiths, another member of Dave's team, a regular member, and I find operating the branch line is quite interesting because although there's just one platform in the station, round the back here, if you know what you're doing, you can actually use 4 different trains and operate them sequentially in and out of the bay platform at the main station. And that's this little bit here. There's also a cassette here where if you need to, you can swap to a different train as part of the operating procedure.
I'm John Malpas. I assist on the running of the layout. One of my favourite areas is the station area with little dioramas, such as the chap painting the fence. You've got the 2 different colours of the fence, where it's been painted, where it's not been painted. The family walking down the hill, the riders. It is my favourite corner of the layout.
My name's Mike Collins. I'm another member of Dave's team, member of the Syston Model Railway Society. But the very first time that we took it out, we did discover a problem with the operating system, in as much as it's operated by a stud and probe, sort of really traditional way of operating points. But when it first came out, you had to touch every stud in turn, all the way through the fiddle yard to set every point. And some of the routes, there's as many as 12 points to set. We weren't getting all the points set correctly. And in my infinite wisdom, having read about it on Google the night before, I said, what this layout needs is a diode matrix. And there it is, my first attempt at a diode matrix. It doesn't need to be as big and ugly as that. I found out afterwards that you can get away with 1 amp diodes instead of 5 amp diodes. But the principle is that instead of pressing all the studs around the route, you just press 1, and then that signal is sent to every point motor that is required to operate for that particular movement.
The layout itself is a roundy because the layout I built previous to this one was just a much smaller layout. It was also a roundy, but I wanted to run longer trains. So that's why this was built in the form it is. In N-gauge, you can get scale length trains running through scale length scenery, really. The fiddle yard is a standard ladder type fiddle yard. Obviously some sidings in there are longer than others to accommodate the longer trains we can run. It's roughly 8 feet. 7'6" I think is the longest of the roads in there, but that's more than enough to get in a 30 van train or an 11 coach passenger train.
If you'd like to see more of Marsh Chipping, take a look at the extras menu of this DVD. You'll note the current issue of BRM has got a bit of a skills theme going on throughout it, And whilst I thought it would be nice to showcase all the different skills in the magazine, one of the ones I didn't manage to get in was that of building a plastic kit. So I'm going to rectify that with the video. And here we have in front of us a kit from Gagemaster. This is part of its Fordhampton range, a brilliant range of easy to assemble kits which would be a step up from the ordinary standard card kits. All you need are a few basic tools, cutting knife, steel rule, a few sanding sticks, and hey presto, with a bit of glue, these things go together, in most of them in the case of a weekend. This here, the one I've chosen, is GM430. It's based on a GWR station, the one at Mortimer. So as you can see from the size of the box, there are quite a few components inside. All of these are pre-coloured in plastic, and whilst we won't be painting the kit today, we will be assembling it, so don't worry about the painting side of things. It represents a station from the 1840s and could be used on the railway today. So very useful for all eras and modellers. On the side you've got a traditional instruction booklet, you can see there. Now this is a little bit like a typical Meccano booklet where you've got step-by-step pictures, arrows showing what to put where. So very easy to follow, and as you'll note from the size of the booklet, there aren't all that many steps, which is good if you're just progressing from a card kit. Out comes the inner component, and then we just tip this out. There we are, put that to one side for a second. So we have moulded in the red brick colour, the red brick. We've got some of the station canopy there, doors and windows. The roof, can you believe it? It's in one section, so there's no gluing on the edges and things like that, very useful. And then the walls, as you can see again, all nicely moulded. And there isn't an awful lot of flash on this kit actually looking at it. All the corners, which is very nice to see, are mited at 45 degrees, which means that you won't get any of those hideous joints on the bricks on one end. So that's very nice to see as well. And even inside, included in the kit, something that you wouldn't actually put on your building, but you might want to put around the outside of your station, is some of the traditional, very nice, ornate GWR spear fencing, and you even get a little station bench thrown in just for fun there too. So let's make a start on the kit and see how easy it is to put together. I'm just using a standard Stanley blade here. Of course the blade has got to be sharp. Don't ever cut with a blunt one because it can slip and end up in your fingers obviously. But what I like to do here is just cut round all the outside of the components of the kit, and you note that they're held in with these little tabs, again not dissimilar to a card kit where they're all retained onto the backing piece. Work your way around, and then once they're free we can just trim off the little lugs there. Now you'll note in the instructions it actually tells you where to cut. It's that basic a kit. So here for instance we've got a little window valance, and we just need to cut off the top there because the lug is a little proud. It's just the way the injection moulding machine has moulded them. And at the bottom we've got two little bits at the bottom there too, which we can just trim off with the knife. Now once all of the components are out, and I like to cut out all of the bits from the kit, have them in a little pile and then discard all the sprues to one side. You can then start to refine your pieces. Now here we've got a couple of little bits of sprue which are still left on this piece, so I'm just going to use a sanding stick, and rather than work across the way like so, where we might end up with more of a ridge on the piece, I'm going to work this way across, you see, and that way we end up with a more flush surface than if we were working the other way, and it doesn't need much work on this at all actually, this piece. There we are, job done. You can also just go a little bit over the edges there to get rid of any little bits of fluff of plastic. So that's the bottom done. We'll give the top the same treatment. Now here we're going to work with the ridge of the plastic rather than file flat, because otherwise we'll end up with a flat spot on top. So just work it around like that. And there we go. You'll note the difference there, the before and the after. And we'll do this with all of the parts, get them in a pile, and then we'll come back and have a look and start gluing. Well, all of the parts are now cut out and I've sanded them so they're all ready to fit together, and it's a really easy kit to do this. Looking at the instructions, there's just a few simple steps. Most of it actually is fitting the brick inserts into these white plastic outer parts. This here is one of the sides of the building, but I'm going to start with one of the ends. That's the way that instructions suggest it, but if you wanted to, it's that easy, you don't even need to follow the instructions. Now the glue of choice I'm using is from Mr. Hobby. It's Mr. Cement Deluxe. It's a solvent adhesive, and as you guessed, we're only going to need a tiny little bit of this on our parts. Now, a good idea is to do what's called a dry run. I'm sure you've heard that before, but all it means is that you're going to test all of the parts to make sure they fit into place without applying any glue. Once you're happy and you make sure that everything fits as it should do, that one for instance fits in there snugly. I'm not going to push it all the way in because we might not get it back out, but once you're happy that they fit into place, you can then just apply a little bit of glue onto the back of them. In this case, I'm not going to apply it to the back of this part, I'm going to apply it into the little insert there, because we won't get any mess on the outside of the building that way. There we are, and then push the insert into place, making sure that it's all the way inside there. If we want, we can use our rule just to get it all the way in. Give it a quick check from all different angles, make sure you're happy with it, and with that done, it's time to crack on to the next piece. Now, here's one I did earlier. You can see the doors fit quite neatly into the backs here with the little window tops cut out, and they just literally a push fit with a bit of glue on the side. So it's time to crack on with the wooden panel inserts. Again, just a tiny spot of glue here. That pushes into place neatly. And we've got a brick insert, which just fits in like so. Again, making sure that it's all in there properly in the corners, and then just checking the instructions. It would appear we've got a little round brick insert which fits into this one, so let's just make sure that that fits. Perfect fit. And then into place we go. So, I'm going to crack on doing this all around the outside of the building, making sure that all these inserts are nice and flush and square in properly where they should be, and let's catch up in a bit. There we go, that's the last part into place now, and all I need to do is glue these to the canopy. Now the canopy is a very nicely detailed piece. You've got all the planks here running along the outside with a little bit of detail there as well. So I'm going to use the same glue to glue them into place. Just apply sparingly though, because this will evaporate on one end by the time I reach the other. So plenty of it on there, work the way along, and then straight into place. Now I've got to hold this a little bit just to make sure that it's all square before I start on the ends. So we'll just work our way around, and on this case we're going to put some on this 45-degree mitre joint. So just applying the glue sparingly again to the corners. We'll just put a little bit on this corner here as well, and along the bottom. There we are. And you'll note that the 45-degree joints on this are brilliant because there's no bricks sticking out where they shouldn't be. So that's another corner done. Working our way around to the other side now. Now there's a good thing about all of these kits from Gauge Master. This isn't the only one that's available from the Fordhampton range. You get a whole variety of structures. You can build bridges, you can build platform canopies, you can build little huts, there's sheds, there's goods yards, you name it. If there's something that's used quite often on a layout, building wise, it'll be in the range. So don't think that this is the only kit that's available, because there are plenty more on its website. And into place we go. This one's a bit of a snug fit, so just make sure they're all in line. What I'm going to do now is just make sure that everything's perfectly glued on the inside of the joints. So I'm just going to work the brush up the inside of all the corners. A bit of a fail-safe this really, just to make sure that everything's got plenty of glue on it and that it'll dry in one piece, because the last thing we want is further down the line, maybe a year or so from now, for this thing to come to pieces. Now the chimneys are a 4-part component. You get the top, you get the 4 little corners that are bent round. This bit then fits into that bit, and then you get another 4 bits that are bent round, and it just means that there's a little bit more detail than you'd get on your average kit. Now that fits nicely onto the roof, which fits onto the building. So let's just flip the building over for now, and we're going to do a quick test fit to make sure that the roof fits into place, which it does perfectly as expected. So let's apply plenty of the glue on this now on the roof. We're going to work our way all the way around the edge. Better to apply too much than not enough in this case, because none of it will be visible. There we are. Let's just flip that over and make sure it's into place okay. There we are. We'll just hold that down for a few seconds whilst the glue takes a bit of a bond, but we can also work our way along the edges here as well from the outside. All of this is going to be painted anyway, so don't worry about the glue turning the plastic a bit shiny. That'll all evaporate anyway. Next into place goes our chimney. I'm just going to do a quick dry run here. So according to the instructions, this one is fitted right dead on centre there. Well, we can gauge that by the doors that are underneath the building, so that looks about right to me. Good splodge of glue on the bottom there. Into place we go. So the other chimney, which goes at the other end of the building, has to go on the right end, and there's a reason for that. At this end here you've got 2 doors, and there wouldn't be much place there for a chimney breast. At the other end, however, you've only got the 1 door, so it's here that the chimney breast goes, on this side of the building, just there. So with that in mind, let's apply a bit of glue to the bottom of the chimney breast and stick it into place. Now there are a few things that you could do to enhance the kit a little bit further. For instance, you could add some LED flashing around the edges of the bottom of the chimney there. But we're going to build the kit as it comes from the box, just to show what you get when you buy one of these kits. There we are. And we're just going to add some guttering now to the kit. So this is 2 little very fine pieces of plastic sprue, which just fit into 2 pre-drilled holes that you'll note on the underside of the building. There's one here, and there's one here down at the bottom on the other side of the building. So that should just push into place like so and run down the side of the building. So you can see there are 3 areas there which we'll need to apply a little spot of glue on, and the same at the top. That's 1, 2, 3, and in the hole there. Push that into place, hold it for a few seconds, and then there we are. So there you go, a very simple plastic kit to put together. Hopefully I've demonstrated a few introductory plastic kit building techniques to you, and if you'd like to get hold of this kit, which is based on a real prototype building at Mortimer on the Basingstoke to Reading line, then visit the Gauge Master website. You'll find all the details on screen below, and don't forget that there's not just this single kit available on its website, there's a whole range of Ford Hampton buildings. So check them out, I'm sure there's one for you.
Okay, here we are with the still unnamed BRM project layout. Howard, today we're talking about points. What do our readers need to know about points in the first instance?
Well, I thought it'd be really nice, given that last month we demonstrated how to renovate it scenically, to start working out how we're going to install some power and actually get some things moving on the layout. So it's a very basic layout, as you saw last month. We've got 4 points. None of them are powered via point motors, so that's something we're going to look at today. But the most important thing, I think, and which is something that many of the readers will probably want to know, is identifying what sort of point you've got. You might have a layout you've inherited, you're not sure which bits are powered at a point, you might not even be that familiar with how a point works electronically. So I thought it'd be quite a good opportunity, given that we're working from sort of ground zero on this project, to go through that whole procedure and install some point motors from DCC Concepts. We're going to go digital with this layout.
Gumph.
Yes, yeah. Well, actually, we're going to use this system. It's from Signatrack. It's called the ACE 2.
Okay, I've got a question for you before
Yeah.
we actually get to this point, though. It strikes me that when you kind of change points,
Yes.
the polarity might change.
Yes, that is very true.
Is that something that the system we're installing actually addresses?
Yes, so the point motors that we're going to install are from DCC Concepts. And just as Andy says, the frog area of your point is an area which changes polarity depending on which track you're on. So I'm going to show that by way of a quick diagram on screen now for you. This sketch from our video department shows the point set in two different directions, top for the line straight ahead and below for the line deviating left. Now the area between the black lines in the centre represents cuts in the rails, and it changes polarity. Above in red it acts as the left rail when continuing straight ahead, below in blue it becomes the right rail when deviating left. It's this section of track that's known as the frog, and making sure its polarity is set correctly is vital.
Okay, I suppose one of the first things we need to do then, Howard, is identify what sort of points we've got here. How would our readers know what to do and what to look for here?
Well, there are a couple of ways you can identify a point, but the ones that we've got on our layout here are from Pico. Now, you might have heard this before, we've got two different variants of point that are very commonly seen from Pico. We've got the Insel frog,
Yep.
and we've got the Electra frog.
And how do they tell the difference between those two?
Right, so the bit of the frog, which is the clue in the title, Insel frog or Electra frog, is this section here. This is called the frog. So it's where your wheel changes from the track across here to the next rail on this side here. So there's this V and the two little check rails here.
Yeah.
Now this as a whole on Pico points is either powered or it's insulated. Now in the case of a insulated point, you'll note there are two cuts and you'll see all of this, most of it will be moulded in plastic. We can tell that this is likely to be an Electra frog point because it's all in rail, but we can double check that just to make sure. And you can double check also on your track at home to make sure that everything's performing as it should be by use of one of these. It's a multimeter.
Okay, now where does one obtain a multimeter?
You can get any of these at your local DIY branch. Most of the shops sell them that are into DIY. Electronic superstores, places like that, we can get one online or throughout the magazine. If you take a look at the retailers that are in the magazine, you'll find that quite a lot of the electronics guys have one of these in stock. So the next question you're probably going to ask is, how do you use it?
Oh, you beat me to it, Howard. How do you use it? You've got some wires in your hand here.
So
what plugs into where?
Right. So there are two ways you can use a multimeter. You can either use it to do a circuit test, or you can use it to measure a voltage.
Mm-hmm.
Now, whichever way you use it, whether it's to perform a circuit test or to measure a voltage, you'll need to use this one in the centre. It's the common return. So that's where we're going to plug in our black cable. There we go. And to measure the circuit test function, so we're going to use it as a circuit tester. To use the circuit tester function, we're going to plug the red cable into where it says ohm there. Can you see that? Plug it in like so.
Okay.
And then on our dial, we've got a whole range of different settings that we can use it on. We're going to look for the ohm setting and we're going to turn it to number 2 there. So you should have on your screen currently a number 1. And that basically means that we're open circuit. So what we're doing now is we've got a little battery inside this device which is generating a current, but it's not flowing at the moment because we haven't got the two leads touching each other. So if we want to test if there's an area of the layout which is connected, are those two bits touching? Have we got electricity flowing through them? If we touch those two together now, you'll see the screen will turn to 0.
Yeah.
There we are.
Eventually.
Eventually, just works its way down.
Yeah.
And that means that we've got a circuit. Okay, if we open the circuit, we're now open circuit, we're back to 1.
Gotcha. Okay.
So there are a few things we want to test on our points. The first is when we're switched in this direction, does this blade make perfect electrical contact with the rail that's next to it, because
Okay.
we're going to rely on the electricity for this coming through onto this rail here. So a good quick fix for that is for me to touch this rail here,
Yeah,
and if you go ahead and touch the rail that's being switched,
this one here.
yep, and it should return to 0. There we are.
There we go.
And we'll do the same if we flick the point the other way. So if I touch this rail here, and you touch
this
that
one here.
yep. And
How
again,
are we doing? It's having a bit of a think.
having a bit of a think, yeah. Now you can see there, if you just bring it down a little bit further on the rail, just to make sure that
Well, we've got a gap in the rail
we have
here.
a gap in the rail there, yeah. But it's coming down to 0.4. And that would indicate that we've got a little bit of a poor connection here between these two rails.
Right.
And this can happen. We have been weathering the track, we've been using some airbrushing techniques, and on a pico point, just down here on the underside, we've got a little electrical pin. Can you just see that on the underside of the point there? We've got a little
Yep.
tab that sticks.
And that's
this,
breaking the connection, is it?
basically, that's to make contact with that. And if we've got a little bit of dirt on that,
Mhm.
then as you can see, we're not getting a proper connection all the way through the point. So that's something we're going to have to look at. So we're just going to work our way around the points now and just make sure that everything's performing as it should do. Okay, so here's a top tip for you. You want to make sure that your drill bit doesn't come out of the other side of the baseboard, or else we're going to be into a whole heap of trouble, really.
And
making a
new
right
points.
Yeah, new points. We basically ruin what we've paid for in the first place, which was good track. So here's a top tip. Just wrap a little bit of masking tape around the end of your drill bit and make sure that the distance between the edge of the masking tape and the tip of the drill bit is the same as the thickness of the wood that you've used on your baseboards. So hopefully we'll make sure that we don't apply too much pressure at the end of the drill. So in here you can just about make out there's a tiny little hole, and that's the one that we've got to put the point motor through. Unfortunately, we're slightly off centre. It was bound to happen anyway. So I just need to mill out a tiny bit more on this side to make sure we've got enough room to be able to flick the point. So let's get cracking with that, and then hopefully we'll all be done. So we've just got the first screw in here on the point motor. Just going to put the rest of them in. So there we go. That's as easy as pie fitting a point motor. Of course, we can't test it until we've got it all wired up, but what we're going to do is get them roughly into the position where we think they're going to be accurate, and then we'll go through the wiring and make sure that that all runs smoothly. So as you can see, the point motor was a very straightforward install, 4 screws, and hey presto, it's into place. None of the screws have come through the other side of the layout, which is great. It means that we're not going to have any problems on that front. So that means it's time to move on to the wiring of the layout. Now, I'm not going to do the whole of the wiring of the layout on this DVD, purely because it's going to be a little bit more complex than just 1 or 2 here and there. But what I am going to do is wire up the point motor, just to give you some pointers as to how simple these things are to operate once you get started. Now, because we're doing this layout entirely with DCC, it means that all we need are 2 wires from the track to the point motor. So first of all, I'm not entirely sure what we've got on the wiring front with the layout, and it's important when you get a layout, especially one second hand, never assume anything on the wiring front where wires might go, because you never know, you do find the odd surprise. So I've got the old multimeter out. I'm going to put it again into resistance mode, and we're going to do a quick circuit test. I've found 2 wires which I think might be from the track. I'm just going to do a quick circuit test on these 2 wires and make sure that we've actually got power from the rails to the end of these wires. But before we do that, we need to strip the ends of them. So these aren't going to be wires that I'll keep when we're wiring up the layout. It's just purely for the purposes of testing this point motor to make sure that we've installed it correctly and it works okay. So I'm going to use the wire strippers here. Now, wire strippers, you can get all sorts of different types. This one I find is quite useful because at the same time it strips it, you can also adjust the length of the amount of sheath that you take off the wire in the first place. So we're going to go for about 10 millimeters here or so, and just strip the end of the wire, so into the red little pointer there, down comes the top, and hey presto. You can also get sorts that are a little bit like a pair of pliers, where you snap onto the wire, adjust the size of the amount that you want to strip, and then just pull it manually. But I find that this doesn't really cost that much more, and it's a much faster and actually neater process as well. Takes all the guesswork out as well of how much the distance is between your pair of wire cutters should be, like you get with those cheaper pliers. So there we go, 2 wires stripped. Now what I'm going to do is put our multimeter as we described before. So it's on the same setting as before, so you can see there we're on 1, which means that we have no contact between the 2 probes, and we touch them together, we get 0. 0, there we are eventually. So that means that we've got a circuit. So I'm going to go with the nearest rail first to start with, just touching the probe there with 1, and we're going to go to the other side of the layout and just touch the track, and hopefully on screen we shall get 0. Fingers crossed. And there we are, thereabouts. I mean, there is a bit of resistance because it is nickel silver rail. So that's 1. Let's go with the other rail just to make sure that we've got everything as it should be. So again, onto the probe and then touch the other rail. 0. So that means that these wires are correctly soldered onto the rail, which is helpful to know. It's also a very handy test that if you can get what's called a dry joint, which means that the wire can appear to be soldered onto your piece of track, but it might not be soldered correctly. There might not have been any flux used during the joint when it was soldered, and you might get a bit of a problem with it conducting electricity. So that's just a quick test to make sure that everything works as it should do. So if we turn now to the point motor, you can see how simple it is really to install wires in this. You don't need any tools at all. It's literally just a push fit. So push down on the contact there. These 2 outer ones on the left hand side, bottom there, see marked DCC in and DCC in. So we're going to go with our furthest rail into the furthest probe, all the way in. This is the DCC system that we've chosen to use with the layout. It's very, very easy to use. Touch screen, as you can see, with some of the parts with this little stylus. And this is a system that I recommend because everything is pretty much segmented as you'd expect it to be. You've got control of accessories, you've got decoder setup, panel drive for a locomotive and the speed, forward and reverse. You've even got a help section if you get stuck. This is a system that we'll be using purely because it's different and I find it's very easy to get on with. So what we're going to do, especially for those of you who are new to DCC, is just talk you through how we set up this DCC decoder, because we have to do a learn function on it, which means that we need to teach it what address it should be. And the way we do that is by a little switch on the bottom here of the decoder. So we need to flick it downwards for it to learn. And we're going to go onto our DCC system. Now each system's different with DCC. On this particular one, it's under accessory control. So all we need to do, apparently, according to the instructions that were with our point motor, is just send a directional change to the point motor for it to learn that particular address. And once we've done that, it says do it twice in the instructions, but we'll just do it another time just for the sake of things. And then we'll flick the switch back underneath here to the normal position, and hey presto, this point motor has now become accessory number 1. As you can see on a system, it's learnt that address and it now knows that to respond to that particular address number. Now here's a handy hint, and something that not every DCC system does, certainly not in a visual format like this one. It'll tell you exactly how many amps your particular point motor or accessory or whatever it is you have on your layout that you're controlling is consuming. So we're now going to test this out to make sure that everything's working as it should do. So we'll just, there we are, so we're in that position. You can hear the point motor switching across. You can also see the wire flexing. Now these are called stall action point motors, which means that when they've completed their throw, the motor stalls rather than shuts off completely. But you'll note that DCC's Concepts point motors aren't consuming any amps at all at their resting position. So this means it's brilliant for the power consumption on a DCC layout. So They state around about 0.04 of an amp. You can actually see the amps being consumed here as it flicks across. It's exactly as they say. Our maximum 0.1 there. Which means it's a good system to have. If you've got lots of these point motors all hooked up together and you want to do, say, a route change setting where you might have 10 of them all changing at once, the last thing you want is a load of power to be drained from your DCC system and potentially affect other things on your layout like locomotives and the sound, and that will be quite obvious. So these are good point motors for that side of things, but also I like the fact that once they've switched across, they lock, and there's no physical way of moving them manually sort of to override them, if that makes sense. So they're very strong and sturdy. So there you go, that's how easy it is literally to use the Signatrack Ace 2 DCC controller with a DCC Concepts Cobalt IP digital point motor. Now if you'd like to check out both of these systems and get one for your layout, you can visit their websites at www.dccconcepts.com, or alternatively for the excellent Signatrack Ace 2 controller, visit signatrack.co.uk's website. We'll look at wiring this layout in its entirety in a future episode. Stay tuned, we're not done with it yet.